Today we are going to be learning about ellipses. Ellipses are ovals. You know them as ovals. Ovals, you've probably not used the word ellipse, but ellipses are ovals, and they're similar to circles, of course, but elongated. Okay? So ellipse, the set of all points in a plane such that the sum of the distances from two fixed points, and by the way, those fixed points are called the foci, is constant. And you learned a lot about these properties when you did your activity that we did. All right, there's two kinds of ellipses. One that's longer horizontally than it is vertically, and that's what's pictured here. That longer axis is called the major axis, and the shorter axis is called the minor axis. Okay? What's a little bit confusing about this picture, the major axis will always, well, the major axis is 2a long, but half of that, of course, is a. So here's what's a little bit confusing. This distance right here is a, but also the distance from here to here, which is this is the foci right down here, is also a. Those things are both a, just so you know. Okay, so we're going to draw some triangles later on, and it's going to get a little bit confusing because you're so used to seeing a squared plus b squared equals c squared, and this is going to kind of break that rule, actually. We're going to kind of move, your a is going to be your c. We're interchanging a and c when we do a squared plus b squared equals c squared today, which makes no sense right now, but it will. Okay, so you're going to kind of use these formulas. Notice there's a plus sign in the middle on these, so always a plus sign in the middle. When we do hyperbolas on the next day's lesson, there will be minuses in the middle. They will be similar, but they will have minus signs in the middle of your equation. Ellipses have plus signs, okay? So what I want you to always know is this. If x is listed first, it's a horizontal ellipse, and your a is always with your major axis. So it's if it's longer horizontally than it is vertically, x will be listed first and the a will be under the x. And of course, if it's longer vertically than it is horizontally, then your y will be listed first and your a will be underneath your y. So a is always the longer axis on ellipses. Okay? So we want to write an equation for this. The foci are at 0, 3, and a has a length of 6. So this length right here, just so you know, is 6. Okay? That also means that this length right here is 6. Okay? So if you connect the foci to the minor kind of vertex or axis point, that length also has a length of 6. So I have a length of 6 here. I can see, obviously, that this is a length of 3. And on this particular one, you can kind of count. It's not perfect, but you can figure out that this has a length right here of 5. Okay? So this axis is longer vertically than it is horizontally. So when I do this, my y squared will be listed first. The a value always goes underneath the longer side. So the a value is 6, and obviously 6 squared is 36. Okay, and then my x value will be listed next. And with that goes the b, and we know that the b is 5, so 5 squared is 25, and always set equal to 1 when you do ellipses. So this is the standard form of an ellipse equation. I do want to tell you that sometimes you'll be given things not in standard form, and in your homework you're going to have to do a problem kind of like this where I want it in non-standard form. To do that, what I want you to do is to get rid of these fractions and get the x's and the y's on the left and your constants on the right, okay? So to do that, you want to know the common denominator between 36 and 25, and 36 times 25 is 900, just so you know. So I'm going to multiply everything through by 900. Okay, and then 900 divided by 36, of course, gives me 25 y squared, and 900 divided by 25 gives me 36 x squared, and 900 times 1, of course, gives me 900. So that would be what I kind of want you to do in non-standard form. Okay? All right, here's kind of a word problem. You have a listener standing in an elliptical room that is 150 feet wide and 320 feet long. The speaker stands on one focus and whispers. The best place, where is you wanting to, it's telling you the best place for the listener to stand is at the other focus. So you are going to write an equation that models this ellipse, assuming that the major axis is horizontal. And again, the major axis is always the longer axis on an ellipse. So the longer axis in this case is 320 feet. So this distance from here to here is 320 feet. And of course, if you take half of that 320, you get 160. Okay? So this distance right here is 160. And of course, that's A. Okay? Then if we look at B, from here to here, is 150 feet. And of course, if you take half of that, 150, half of that would be 75. So that much is 75. Okay. We know that the longer axis is a horizontal axis in this case. So when we make our equation, I am going to use this model right here because the longer axis is horizontal. So I will have x squared over a, which is 160 squared, and when I square 160, I get 25,600. And then y squared over b, which of course is 75, and when I square 75, I get 5625 equals 1. So there's that equation. Okay, and then the next part to this, how far should the speaker and the listener be in this room? And remember, it told you that the speaker and the listener should be at the foci, the two foci. So I have a foci here, let's say, and I have a foci here. And I'm just really totally estimating where those foci are placed, but I'm estimating it, okay? So here's what you need to know. Remember how I told you if this was 160, I can also tell you that when I connect my foci to my minor axis, this is also 160, okay? In this case, what I don't know is I don't know that, okay? And actually that distance is not, I'm going to not call it x, I'm going to call it c. But this is why this gets confusing. When you're doing the Pythagorean theorem, I wish they would not have called it c, because when you're doing the Pythagorean theorem, you need to set it up like this. So you need to set it up as c squared plus 75 squared equals 160 squared. Notice it's not set equal to c squared. Your hypotenuse has to be the c value. So in this case, your hypotenuse is 160. Okay? So when you set that up then, of course, you have c squared plus 5625 equals 25,600. And so then c squared is 19,975 when you subtract. So c is the square root of 19,975. And that's a really big number. I'm not going to expect you to break that down perfectly in a radical and make it be like 2 root 4 or anything. Obviously, it wouldn't be 2 root 4. But I'm not going to make you do that. I'll let you get decimal values here since it's a word problem anyways. And when you take the square root of 19,975, you get about 141.33. So this distance from here to here is 141.33. But the question asks me how far apart should the speakers stand. So of course you need another 141.33 right here. And so if you double 141.33, you get about 282.67 feet. Okay, and that's about how far they should stand. All right, I want you now to manipulate this equation so that it creates a different equation that generates just the top half of the ellipse. Okay, we did this when we did circles too. And remember, if you want to generate the top half of something, you need to have this equation solved for y, okay? If I want the left and the right half, then you need to solve it for x. But the top and the bottom halves will be solved for y. If I want the top half, it'll be a positive square root. If I want the bottom half, it'll be a negative square root. Okay? So in this case, I'm going to solve this equation for y. And I want to basically kind of get rid of those fractions first. So 16 times 25 is 400. Excuse me. I'm going to multiply everything through by 400. And when I do that, then I will have 25x squared plus 16y squared equals 400. Okay, now if I want the top half, I want this equation solved for y. Okay, so I'm going to go 16y squared equals, I'm going to move this 25x squared to the other side. So 400 minus 25x squared, divide by 16. Okay, so y squared equals this mess now. Okay, and then of course square root it. Now, if I want just the top, technically when you square root this, you should have a positive and a negative. The positive square root gives you the top part of the ellipse. The negative square root gives you the bottom part of the ellipse. So if you have the plus or minus in front of there, you're going to get the top half and the bottom half. Okay? But if I want just the top half, then I'm going to leave just the positive root in there. And I really don't expect you to simplify this any further than this. Just leave it like this. I know we have fractions. It's okay. I know I can take the square root of 16, but actually you'll probably be presented something that looks more like this anyway, so I want you to kind of recognize that form. Okay? Then if we were to do the next one, this means I want the left half. So if you want the left and the right half, then you want it solved for x. Okay? And of course, again, you would multiply everything through by 400. I probably don't need to repeat this part of it again. But when I multiply everything through by 400, again, I will have 25x squared plus 16y squared equals 400. That's the same as the last problem. If you want the left and the right halves, then you need to have this solve for x. So I am going to move that 16y squared over so that it looks like that. And then, of course, divide by 25. And then, of course, you want to take the square root of both sides. Okay? That just undoes itself. And then you'll have, if I want the left half, technically you should have a plus or minus in here. Okay? The plus gives you the right half, the negative gives you the left half. If I just want the left half, then I just want the negative root. So it will look something like this. Okay? Then that will create an ellipse as well. All right, now we need to look at ellipses that are not centered at the origin, okay, because then they get a little bit trickier. There's the formula for it. We'll kind of talk about it as we go, okay? So here's an ellipse, or that oval shape, that is not centered at the origin. The x is listed first in this case, and because the x is listed first, I know that I am dealing with an ellipse that's got that's longer horizontally than it is vertically, okay? This gives you your h value. Your h always goes with your x, no matter what. Okay? And again, this is technically x minus negative 3. So your h value is negative 3. And then your k value, you can see, is 1. That's going to give you your center. So you are going to be centered at negative 3, 1. And I'm just going to plot that point right now. There's my center. Okay? I know this is going to be longer horizontally than it is vertically. If you look at your formula, here's your a squared. Here's where a squared is here. So a squared is 20, which means a is the square root of 20, which is also 2 root 5. In order to make that on a graph, you kind of need to know the decimal value for the square root of 20, and the square root of 20 is 4.47. Just so you know, the only reason you want that is to be able to plot your points more accurately on your graph. So again, the a in this case is underneath the x, so that tells you that you're going to go the square root of 20, or 4.47, along the x, the horizontal axis in this case. So I'm going to go 4.47 to the left of my center, and 4.47 to the right of my center. Okay? And that's going to give me my longer axis. All right. Then, of course, b squared is right here. So we know that b squared is 16, and then obviously b will be 4, much easier to count. So now I'm going to go 4 up and 4 down. And this ellipse is pretty circular. There's not a whole lot of difference between your major axis and your minor axis in this case. But there's my ellipse. Okay. So it asks me to find some information about this, and I can get some of that pretty easily. I already know that my center is at negative 3, 1. I figured that out pretty easily. Okay. And now I want to be able to find my foci. Okay. So in order to find your foci, you kind of have to be doing some calculations here. Okay, so when you think about this, this distance right here, remember, was the square root of 20. That is also the same distance, and I am estimating where my foci are right now. I really don't know where my foci are, so I'm estimating them, and I might need to move them. But I know that my foci are, let's say, here and here, and I'm totally estimating. Okay, I really don't know. But because this distance right here was the square root of 20, when I connect my foci to my minor axis, this distance right here is also the square root of 20. Okay, so there's your square root of 20. All right, let's say my foci is right here. Okay, this distance we know to be 4, and I don't know what that distance is right there, and that's what I'm going to find out. Okay, so I am going to go x squared plus 4 squared equals the square root of 20 squared. So x squared plus 16 equals 20. So x squared equals 4. And obviously x is 2 then, and we're talking about distance, so we need positive roots. So I didn't put my foci in exactly the right spot, but I know that this distance right here should be 2. So I'm going to move this foci so that it's exactly in the right spot, and this foci should be put right here at exactly 2. Okay? So my foci, I can see this point right here. If you look at your coordinate axis, is 1, 2, 3, 4, 5 to the left and 1 up. So this point is at negative 5, 1. And then this point right here is at negative 1, 1. Okay, so there's my foci. And if I want to know the length of the major axis and the minor axis, okay, so the major axis, we already talked about how this distance right here is the square root of 20, but you have 2 of them. This distance is also the square root of 20. So the major axis will be 2 times the square root of 20, which of course is 2 times 2 root 5, which is 4 root 5. And that's how I want you to tell me how long the major axis is with radicals in there, not with decimals. I would like them with radicals. The minor axis, of course, we know that it's 4 from here to here, and it's 4 from here to here. So when we add 4 and 4 together, of course, we get 8. Okay? All right, and one last one where we've got to complete the square and do some other stuff with it. This, again, is going to be one that is not centered at the origin. It's going to be centered somewhere else, so we're going to have to do a little bit of work here. Okay? When you do this, when you complete the square with this, you want to group your y's together, okay? So you're going to have y squared plus 4y. So I'm grouping these and these together. And then I'll group my x's together. 4x squared minus 24x. So I grouped that and that. And then I want to move this to the other side. Equals negative 24. Okay, now you're going to need to complete the square. And when your numbers in front of your squared terms are not 1, when you're doing ellipses and when you're doing hyperbolas, also tomorrow, you're going to need to do something special. Okay? Luckily, with your y's, the y, what the number in front of there is 1, and you don't need to do anything special. But you are going to go like this then. Y squared plus 4y plus some number right here. Okay, so you're going to do that. And then, here's the deal. The number in front of my x squared term is not 1. So what you need to do is you need to take these two things right here, and you need to factor this 4 out of here. So I am going to factor a 4 out, and then I will have this, x squared minus 6x plus a blank. Okay? So, because 4 times negative 6 makes negative 24. And then over here, of course, I have negative 24. And then I need 2 blanks, because I have 2 blanks on the left, so I need 2 blanks on the right. Okay? So then over here on my y values, of course, half of 4 is 2. When I square 2, I get 4. So I'm going to put a 4 there, and I'm going to put a 4 here. Okay, and over here you got to be careful. X minus 6, half of 6 is 3. When I square 3, I get 9. Here's where people make a mistake. Ready? What goes in this blank over here isn't 9. It's actually 4 times 9, which is 36. Okay? So be careful about that. Then on the right side, if I have negative 24 plus 4 plus 36, I will get 16. Okay? And of course, when you do ellipses, you want that equation to equal 1. So I'm going to divide everything through by 16. And then I will have y plus 2 over 16 plus x minus 3. Oops, I forgot my squared. Squared over 4, because 4 over 16 reduces to 1/4, equals 1. So here's my equation for my ellipse after I completed my square. Okay, so again, the h value for the center always goes with your x. So this tells me right here that my h is 3 and that my k is negative 2. So I can already tell you that my center is at 3, negative 2. And I'm going to go ahead and plot that point. 3, negative 2 is my center. Okay. My y is listed first in this case, so I know it's going to be longer vertically than it is horizontally. Also, the bigger number is under the y-axis. Do you see that? Or underneath the y? That tells you it's going to be longer vertically than it is horizontally. Okay? So, this right here is your a term. A squared is 16, so of course we know that a is 4, which means I'm going to go 4 up from my center and 4 down from my center. Okay. B squared is 4. So the square root of 4 is 2. So I'm going to go 2 to the right of my center, 2 to the left of my center. Here's what my ellipse will look like. I kind of got that off a little bit, but you get the gist. Okay, now I'm worried about finding my foci. And I know that my foci, and again, I am totally estimating this. Let's say your foci are here and here, and they are very possibly in the wrong spot. Okay, I am simply estimating at this point, and I'm just estimating so that I can kind of draw a picture. Okay, so we know that from here to here is 4. That's also the same distance again if you connect your foci to your minor axis. So this distance is 4. This distance we know is 2. This is the distance that I don't know. Okay? So I'm going to go x squared plus 2 squared has to equal 4 squared. So x squared is 4 squared, which is 16, minus 2 squared, which is 4. 16 minus 4 is 12. So x is the square root of 12, which of course if you break that down is 2 root 3. And if you want to be able to graph your foci appropriately, you need a decimal for 2 root 3. And I think the square root of 12, which I don't know what it is as a decimal. The square root of 12 as a decimal, let me punch this in, is 3.46. So I actually should be moving my foci down, down a little bit. So if my foci were 3.46 from my center, this foci should actually be right here, and this foci should be actually right here. But I'm not so worried that you get those in the exact right spot right now. I just am having you use them so you can picture how to calculate your foci's distance, okay? So I know that this distance right here now is 2 root 3, okay? So here we go, your foci. So this foci up here, your x value of that foci, of course, is 3, because you're 3 to the right. And then your y value, your center started right here at negative 2, but then you went 2 root 3 up from that. So you'll go negative 2 plus 2 root 3. And then, of course, you'll have another one at negative 2 minus 2 root 3. And if you want to just list that once and then list it like this, 3 and then negative 2 plus or minus 2 root 3, and just list one foci, I'm fine with that. That's fine. Otherwise, you can list them twice so that you can understand there's 2 of them. But there's your foci. Okay, then if we talk about the length of your major axis, your major axis, of course, is this distance here. Whoops. Sorry, all the way down to the bottom, which we know is 8. So your major axis is 8 long. And then your minor axis, of course, is this distance from here to here, which we know is 4. Okay, and we have found everything we need to find. And that'll do it.